the screen inception, it is because my morning video maybe has failed. I can't quite tell. So it's still trying to upload, but I need to get something uploaded because we have multiple kids absent. Just write a note. You don't have to try to solve it. Just write a note. Come on, who cares? Get out yesterday's notes, please. Get out yesterday's notes, please. With the hot dog and the hen on the back, but I don't think we did the problems on the front. Somebody correct me if I'm wrong. So we did the triangle problem? We did this problem? And we did this problem? Okay, so the next one then uses a scale factor that's a mixed number. So, again, if anyone loses notes or whatever else, out here in the bin on the top of it, like, is where I just keep the extra notes right now because they don't blow away. So, oh, you need a copy too? These guys. Yeah, what's new?
What?
I was just informed that I'm loud.
You are my brother.
Was that Keegan that walked by?
Yeah.
Oh my gosh, I didn't see him this morning. Did you guys get here on time?
No.
I don't think you can make breakfast. Ooh, I tried to oversleep. It was really nice weather this morning. Like I wanted to keep sleeping. Guys, you can. Guess what? It's raining. Hey, so I'm going to lay this out again as like a reminder. We have very limited amount of time left before the state test. I don't really care that much about the state test. We have very limited amount of time left, period. We have like a month left with each other. That's it. Now, yeah, I agree, right? It's been a heck of a year. I kind of agree. But some of you have a lot of work missing. And reminder, that doesn't go away because you chose to come to Phoenix. So, we need to use our class time efficiently. You need to take notes that you then go back and use while you're trying to do your Khan Academy. Guys, I've talked to so many people as I try to help them with math, and I'm like, look in your notes. This problem is in your notes. Literally, this problem is in your notes. Like when they come and they're like, I need help on this. I'm like, I did this for you. I did it in class. Now, that doesn't always happen, but sometimes does. So, I also am like your partner in crime, or whatever you want to say, to help you try to avoid those traps, right? Those mistakes that they set up to try to get you. One of them is using a mixed number scale factor. We can use a mixed number scale factor. It is true that going from figure A to figure B, we could multiply by 2.5. But remember what we said we liked better than mixed numbers? Improper fractions. Clark, what would this be as an improper? 5 halves, or 5 over 2. Now, why do I care about using 5 over 2 instead of 2.5? Well, I'm not going this direction when I try to find my unknown. See who remembered that we have to multiply?
Well, I mean, I caught myself. I was about to say we had to divide.
See why I react the way I do during class? Because now you remember. We don't want to divide. We want to multiply. But by what, Charlie? The reciprocal. So what everyone should be writing down on their paper is that to go from 5 to x, because we're going the opposite direction, multiply by the reciprocal of the scale factor. Question? We're on the front. Right. Oh, good. Yeah, we're on the front of yesterday's worksheet. Is anyone else lost? Need help finding this problem? On the front of the worksheet, have the triangle, the quadrilateral. Any questions on the fact that when we go backwards, we use the reciprocal? If you don't have a question, do the next one. Yep. Now on the back side, that space beneath those problems on the back, because I'm going to show you exactly what I want you writing back there. Gotta keep that space beneath the hot dog. So, if you're trying to find the x, they tell you the scale factor, and we just have to decide, am I going the correct direction for the scale factor, or am I going, quote unquote, backwards for the scale factor? So to get x, I see that it corresponds to 16. But then I ask myself, am I going the direction that they tell me to go from A to B? Am I going the right direction? No, right? To find my x, I got to go backwards. I got to start at 16. But if I'm going backwards, I don't use 4/9. I use 9/4. When we're going backwards, we flip the fraction. So the math that we could write out, I mean, you can also do this in your calculator, but it's 16, which we can put over 1, times the 9/4, which makes sense because we're getting bigger, right? The blue shape is bigger than the green shape. 36. I think it came out.
No, it's 36.
Is it? Okay, I thought it was 32 earlier, but maybe not. Yeah, so before we simplify, what was it over 4? 1 what? 144. And then when we simplify, we get 36.
Oh, that makes sense.
Are you or aren't you?
No, because I was trying to see 4 times. I was like, it's 9/4. But no, it's not. I don't understand what I'm doing.
So, as a reminder of how we use our calculator and fractions, because somebody asked this yesterday, and I realized we should give a reminder of it. Reminder of how we use our calculator and fractions. You want to take your 16 and multiply by the fraction, which if you've learned how to use the fraction buttons, there is a fraction button, but I don't like to use that because the safer option that works in any calculator, guys, not every calculator has a fraction button, is parentheses, type in your fraction, 9 divided by 4, hit the wrong button, and then we get our answer.
What number did you play?
Oh, sorry. Yeah, so we get 36, and we got to calculate that. Yeah, so that's why 36 is bigger than 16. Right? We're going from small to big. So x, what you want to label on your paper is that this x we just found out is 36. That edge is 36. Now, the other way we could deal with this problem, just to talk about this real fast before we move on, when we talked at the bottom of the page of notes about making units agree, guys, we can also do our b over a. Remember how we talked about that's always our scale factor, is the new over the old? So what if I did 16 over x, so that's b over a, equal to, well, isn't our scale factor b over a? So if this is b over a, we could also set up this is b over a. And that's actually what we're going to do for the next problem with the hot dog.
Yeah, that one doesn't. On the back.
Well, that's because there's no mustard. Oh, wait, there is mustard. Whoa! Because you're a child. Don't worry. You'll grow into mustard. Kids don't like mustard. What? Are you not a child? Whoa. This is the largest reaction I've gotten from anything I've said all year, I think. And we're just talking about mustard. So, we're going to set this up and make sure that we make units agree. What do I mean by that? If I put centimeters on top and I put units on bottom, I have to keep that the same. If I set it up the other way around, like units on top, that's okay, but I gotta keep it the same. So all of us need to agree, if you haven't done this yet, I'm just gonna go ahead and do centimeters over units. So I'm gonna set up everything centimeters over units. I go ahead and I write that down to make sure that I stay honest and make sure that that is what happens. The first thing I do is I look at what they tell me for the scale. How many centimeters and how many units? Well, they tell me 10 centimeters. You could be writing this beneath this problem, by the way. This is where I have space on the board, but I left you space beneath. So I'm going to make sure we're not just spacing out the window. What units amount goes with my 10 centimeters? Yeah, 6, because if we count right here, it is 6 units. So this, we got a 6. What else do we know based off what the problem tells me? The hot dog in the drawing is 9 units long. So, would I put 9 on top or bottom? Bottom, because that's where units are going. That's not like a rule. It's just how I set this up. Okay, I set it up to be units on bottom. Yeah? Well, I could have it. Did you say I don't know?
Yeah, you did.
Sorry, I just need you to speak up. Look, I just need you to speak up because I can't with air purifiers on. Which math? Did you do this math? So, what relationship you're recognizing with, now just be careful when you say it's just logical, because some people don't see it really quickly. I'm betting that in your brain, you're relating that if I look at 5 centimeters, that's 3 of the boxes, and we could go 3, 3, 3. But for those of us that isn't obvious to us, because it's not obvious to me, there is a technique that absolutely always works. Put a variable up here for what we don't know, and we are going to cross multiply.
Oh, no.
Guys, cross multiplication is like a magic pill or whatever you want to say. It always works, no matter how bad the numbers are, no matter how big the numbers are. Get a calculator. I'm not asking you to do I'm not even asking you to do work. I'm just asking you to grab a calculator. 6z is now equal to 9 times 10. I should really do that in a different color. So then, how do I get rid of that 6? We divide. And then we get 15. I agree with you. But for some of us, that's a little tough to see. And that's 15. Grab your label that you need. Centimeters. Do the same thing for the next problem. Even though you can count it like I want you to set up a proportion. I'm going to leave this up here so you can finish copying. Don't ask me questions about the hen as I walk around. I'm not going to help you. I want you to try it on your own. First thing you do is just set up a fraction equal to a fraction. And then you start filling in numbers. Fraction equal to a fraction. This is not this easy. So this is why I asked a few times you're getting the classes yesterday. For what? Did you have yesterday? Okay, so we need to go take notes. Layla, you gotta speak up sooner. Right, when you go to the bathroom, it's your responsibility to make sure you have what you need when you come back. Okay, this is like, that's kind of a big deal that you missed writing all of that stuff down. So, I kind of need you to come see me at extensions so we make sure that you know what's going on, since you obviously missed writing some stuff down. So go ahead and try that with the hen. Make sure that we put units into the proportion you set up. Not using a calculator before we write things down. Not using a calculator before we write things down. Yeah. I solve them the same way using proportions because it always will work. Alright, random card time. See who's awake, alive, alert, enthusiastic. Who's been to summer camp, heard the song I'm talking about? I'm alive, alert, awake, enthusiastic. Okay, okay. I'm alive, alert, awake, enthusiastic. I'm alive, alert, awake. I'm awake, alert, alive. I'm alive, alert, awake, enthusiastic. He can just walk by again. I just had to finish it because of him. I'm sure he loved that. Samaje, what is the scale they tell us? Is how many units? Absolutely. So if we want to put centimeters over units, that's a 1. Good job, Micah. Hey, look, math is hard. Then, Megan, what else do we know? Yeah, the hen is 16 units tall. I also got a very big reaction this morning saying that there wasn't a difference between a chicken and a hen. They got very mad at me.
It's a male and a female.
See, y'all don't know either because you're city slickers. If you don't know what city slicker means, you are a city slicker, probably. City slicker is the term that people from out in the country call people who grow up in a city because they don't know country things. Yeah, so when you get called a city slicker, normally it means you're a bit cleaner and you have a bit larger of a vocabulary, and they're just like, oh, that's city slicker. It's not a bad thing. Huh? I would now, my friends who still live where I grew up, they would now call me a city slicker. Because I live in Delta.
You can change from one to the other.
I don't know, that's a good question. But alright, back on the topic, we know 16 units. I don't know how tall the hen is, so I'm just going to put some variable there. I'm going to go ahead and put centimeters. If you're trying to shout out the answer, I don't know the answer yet. Question? Okay, do it. Yeah, sure. So I agree that will work, but what I specifically said was even though we can count, I want you to solve the proportion. So here's the trapdoor you're falling into, Clark. You're thinking, I'm going to do this the easiest way because I see that these numbers work nice. Because they do. They're nice working numbers. That won't always happen. So I'm trying to You guys can be annoyed at me. I'm totally fine with that. I know why I'm doing what I'm doing. So Leah said something else that is correct. If I look at what 1 unit is worth, that would be 3. But I don't need to do that. I can, but I have a proportion and a calculator, and I'm ready to just solve. How do I do it?
You do 6 times 16 because you need to cross multiply. That equals 98. You need to do 2 times 8, which equals to 8.
Hold on, slow down.
Yeah.
I know, I'm the one saying slow down, chill out. But, so you said do the 2 times h and we get 2h. Okay, so now.
So then, 2h equals 98. 98 equals 2h. You then need to get h by itself. You need to divide 98 by 2, or 2 by 98.
Well, you
Well,
can't.
98 by 2.
I was about to say you can't say it either way. You have to say it the right way.
And then that gets you 48. 48.
Guys, and I know that there are plenty of you who got this correct answer in a different way, but on the next problem, yeah.
Oh, yeah, never mind. Yeah, because you're trying to do it.
See what happens when you get all excited and talk too fast? You say the wrong numbers. That should be right. Sorry, 96. Please correct that if you wrote down what I wrote down. The next couple problems aren't as nice, right? The numbers aren't all even numbers. They don't divide all nicely to each other. So another nice option up here, but it's only here because this is nice, would be if I go way back. And Clark, this is kind of what I expected you to say, because this is kind of how I think your brain works, especially when you said I simply. I really expected what you were going to tell me was you simply looked at this. Did anyone look at that? What is that, Harish?
You just multiply by 8.
This is just a times 8. So if we think back to proportions, if this is a nice number, we can just do this. And that's times 8, which gets 48. So there are multiple ways to do this, but this problem is nice. They often aren't. Because, math. So here, this problem isn't terrible, but it's definitely not as nice. Set up a proportion, right, fraction equal to a fraction, to solve this. Start with the scale. Doesn't matter what you put on top, but I'm in the habit of centimeters on top now, so might as well. What else would I put where to finish setting up my proportion? I'll let you pass after I ask you one more question. What other numbers do we have? There we go. Okay. What's the label on 25? So would it go on top or bottom? I tricked you. You wanted to pass, but then you answered the question. I win. Let's not go. She knew what was that. She like polarized me. She knew what was that. Colin, do I know how many centimeters? No, so variable, I don't know what the math distance, D, I don't know, D for distance. It doesn't matter what variable we use. Guys, take a moment to make sure that you know how to cross multiply. We multiply the diagonal pieces, and I always circle or highlight or something. The one that a lot of kids get messed up on is the number that then goes with the variable just is that times the variable. It's just 10D. The other one, 3 times 25, what's that? 75. How do we get D by itself? Divide by 10. It is 7.5.
Okay, because I was put something I don't know.
Do that final problem on your own. do that final problem on that paper on your own, then we're going to switch to that next page. You might recognize that these numbers are kind of nice. Did anyone recognize that they're sort of nice?
Yeah.
What, Delaney, I see you nodding back there. Can you tell me why they're nice? Yeah, exactly what Delaney said. We can do 3 times 9. When you set up the proportion, I just got in the habit of centimeter on top. Thank you. So if you recognize that they're nice, we could do this. But we don't have to. We could cross multiply. So I'm going to give highlighting to make sure we know where these numbers came from. Cross here gives us this big 162. And then cross here gives us our 3b. When we divide by 3, either way, we get 54. Preguntas. Miss Rubber Pencils. I promise you it does not actually become rubber. If you've never seen, it works better with a wooden pencil, honestly. If you've never seen the whole Kiki and Bella were doing this thing, where it's supposed to look like it starts to be flexible, but it's just your eyes playing a trick on you. All right, get out the other notes that I am going to be real upset if this didn't work, if these pictures aren't actually here. I'm going to close this and come back. Yeah, so 1, that wasn't for you guys. That was for a different class. 2, control your reactions. 3, that only happens because they're all done with their homework. We're not all done with our homework. Yeah, they were done with their homework, so we went outside and they got to do whatever. All right, so does everyone have this page of notes? Okay. Follow the directions on them. Draw a 5 by 5 square. Then use a scale factor of 3, which would then make us draw a 15 by 15 square. You guys are welcome to discuss this with each other after you find the area of each of them. Talk to somebody close to you. What happened? Did that scale factor of 3 apply to the area? If not, what did happen? times 15. Guys, make sure you put a u squared after this to make sure you remember that labels are important. You're going to get your quizzes back tomorrow, the ones we took last week. We were on spring break last week. We took them before spring break. It was the circles quiz. The rotations, the hamster wheel, the hamster quiz. Okay. But a lot of us, we're dropping labels, right? Labels are important, guys. Let's try to keep our labels. You said the area here is 225? Yeah. Guys, talk to each other. I don't think that's a times 3. What the heck happened? What happened to the area? Because guys, what's 25 times 3?
75.
Yeah, not the number we got. So what I'm asking is, what happened? Talk to me. What happened? Say it again. You're right. Valerie, I don't think whispering in your mask is really working.
It's not.
It's just not working. I'm sorry. I feel bad. I can't just talk to her because then you're too close together. So I think just write a note or wait till after class maybe. Maybe wait 8 more minutes while the teacher finishes teaching, and then maybe I can't control what you do. That's one idea. I am gonna call on Maggie though, because it's. So, hold up. Bring it back. Maggie, what you said sounded really clear, accurate, concise. I don't know if you guys know concise. Concise means good, condensed. Can you say it again for everyone? But you said something else about why not? Yeah, so guys, we said take this shape and make the width times 3. So essentially go times 3 that way and go times 3 that way, which means we actually did times 9. Right, now hold on, because I heard some people making some hypotheses and making guesses about what happened. If instead our scale factor was 2, and we were doubling the width and doubling the height, what would happen to the area? It'd be times 4. What if I did times 5 that way and times 5 that way? It'd be 25. So guys, what we see here is if the scale factor, actually I'm just going to show you my notes. What are you doing? It broke. Here's what I want you to somehow get on your paper. Well, hey, can you guys not react so crazy quick? Calm down. I got you. So, the linear scale factor, the length scale factor, was 3. So, make sure that you notate that your length scale factor was 3. What we did was 5 times 3 to get our 15 over there. But what happened with our area going from 25 to 225 was times 3 to the width and times 3 to the length, and times 3 is 9. Ah, what?
Wait, what did you do? A times 3, the first circle?
This?
Yeah.
Length. Sorry, length times 3, width times 3. Sorry, that's a cursive L. A non-cursive L looks like a 1, right? I don't like L, but yeah. Cursive L.
It looks like a B. It looks like a B in cursive one and L. Or maybe the rest.
Length times 3, width times 3. Oh, and then, hold up, hey, all your off-topic conversation is unhelpful right now. And then, if we went backwards, remember, reciprocal, we do not divide.
Well, you multiply by 9 over.
Reciprocals, if we go backwards with the length, it'd be a third. If we go backwards with the area, it would be 1/9. So if we go backwards, we just split the fraction. Didn't what? Why? What?
I don't know.
Okay, well.
It makes sense for now. I think it's all the writing on there.
Yeah, there's a lot of writing up here. So you don't have to write all that down. You can just write down whatever you feel is important.
Okay.
But, well, if you did, good. Hey, why would you erase? Those of you who just flipped your pencil over, if you already wrote it, leave it. So when we're given a length, I know I have writing up there. When we're given a length scale factor, if we were to call that like F, and I'm actually going to switch over my other screen. The length scale factor, we could call F. What I'm trying to make is so there's less writing, since you guys said you didn't like it. If we call the length scale factor F, like in this case it was 3, and the area scale factor was the scale factor times itself, what's an easier way to say a number times itself? Squared. What do you think would happen if I did times 3 that way, times 3 that way, and times 3 that way? Oh, it's huge. So really, that is F times F times F, right? We multiply the width and the length and the height. Yes, that is, yep, volume. Yep, volume. Good.
I don't either.
So, look down your worksheet to the next problems.
What time is it?
52.
It was 4 minutes.
I'm so sorry, your torture will be done very soon. So, these, when they give you the scale factor, is the linear scale factor. The linear scale factor. Now down here, still they give you the linear scale factor, but it's kind of a slightly different problem. So take a moment, we're going to random card and get some volunteers to help us out. It is when you're in public school. She said that's not what volunteering means, and I said it is when you're in public school.
No, it's just undercover volunteering.
I get voluntold to do things all the time.
But I mean, I'm a kid, so I don't have any people saying anything.
You guys already answered this question for me today during class, just not on your paper. If the linear scale factor was 5, and we did times 5 and times 5,
25.
the area does times 25. So we would take polygon A times 25 to get area of B. Ooh, we're getting smaller though. So Grant, if we used to sit on that side and then I moved you, I don't know why. 1/4, well, if I go 1/4 this way and 1/4 this way, what actually happens? Huh? Yeah, but what happens to the area? What fraction could be used to describe the area change? We got to square that linear scale factor. Guys, notice this note. I would highlight this note. When you apply a power to a fraction, we just apply it to both of them. Meaning here, we're going to take 1/4, and to square it, we square the 1 and we square the 4. Well, 1 times 1, that's just 1. But 4 times 4, 16. So guys, I don't know if anyone in here plays chess.
Yeah.
But if you think about a chessboard or any board with a grid on it, you can think about scaling really easily. So if you take 16 of these, that'd be 1 quadrant of the chessboard. That would be the bigger area compared to just 1 square is a 16th of the area. It's only a 1/4 of the length, but the area gets cut in 16 because of how impactful it is. This is not the one I made. Yeah, we'll pick up there tomorrow. I'll come around with lights. Sorry, class, I on your paper. So do your homework, and then as the year goes on, we'll have days where we can just do fun stuff. Yeah, it is still raining, so Charlie's lying to them.